to Introduction to Chemistry lab course. My name is Dr. Langat, Langat, originally from Africa, Kenya. I came over to United States close to 20 years ago to go to school. I got my bachelor's in chemistry from Bethune-Cookman University in Daytona Beach, Florida. Some of you may know where it is. I got my doctorate degree in analytical chemistry from Howard University in 2008. Since then, I've taught at different colleges and universities. I taught before at College of Central Florida from 2008 to 2009. Beginning 2009, I came to Jacksonville, not UNF, but I was teaching at Florida State College at Jacksonville from 2009 to 2018. Beginning 2018 fall, I moved over to University of North Florida as a laboratory instructor. I've taught several courses, and this semester, even though I will not be your lab instructor, but I will be your lab partner. My job is to perform the experiment where applicable, and your job is to collect the data and perform the calculation as per your instructor, following the guidelines and the instruction. We will be working along with my colleague, Dr. Matthews. You may see him down the line. Nevertheless, for today, I just want to welcome you and say welcome aboard. Stay on board. I will simplify the concept as much as I can. On a personal note, I love reading and running. I intend to, or I plan to run a marathon this year, but the pandemic changed everything, and I had to put everything on hold. Other than that, welcome aboard. Let's go to the lab and see what's up for the past experiment. Welcome. Let's get started. First thing is you have to put on your goggles. We're ready. This is our lab. I'm gonna be doing the demonstration here. You may not see my face, but I hope you'll hear my voice and you'll collect the data. As you know, this is our first experiment. It consists of five parts. Part A, which we are going to look at the measurement of length. We will measure the length of 13 by 100 millimeter test tube. Part B is the mass measurement. We will measure the mass of evaporating dish and mass of the crucible with the cover using decigram balance that measures 1 to 1 place of decimal, centigram balance to 2 places of decimal, and milligram balance which measures up to 3 places of decimal. Part C, we will look at the volume measurement. We will look at the determination of volume by calculation of unknown solid. You see that, and take the mass of the unknown solid using the decigram, centigram, and milligram balance. Then thereafter we will see volume measurement, and lastly temperature measurement. Welcome. Part A is measurement of length. We are going to measure the length of 13 by 100 millimeter test tube, which I have on my hand right here, or you can see on the other side of the screen. If you can see the dimension, you can see on the other side. So I'm just gonna place next to metric ruler A, and your job is to record the length on your data sheet. That is the length using metric ruler A, and metric ruler B is down here. I'm just gonna move to metric ruler B. Please record the length of the test tube in your data sheet. This is metric ruler B. Next, you will record the diameter of the watch class and the evaporating dish. I'm gonna start with the watch class using metric ruler A, and you should record the diameter. Hold on, I think right there you should record the diameter of the watch class using metric ruler A. I'm gonna move on to metric ruler B, and you will record the diameter as well. The diameter of the watch class. This is the watch class, and yeah, it's about there. You have to record the diameter of the watch class. That is the watch class. I think just right there. That is metric ruler A and metric ruler B. I'm just gonna take this away and bring over the evaporating dish. This is the evaporating dish, and we don't want to measure including the sprout. It's just this side where we want to determine the diameter. I think it's about right there. You can record the diameter using metric ruler A, and metric ruler B. We will do the same thing. You should be able to see where the edge is with respect to metric ruler B. That is the diameter using metric ruler A, and metric ruler B should be just about there. Okay, you can record the diameter using metric ruler B, and that marks the end of part on measurement of the diameters. In part P, you will record the mass of 125 LMR flask, crucible and its cover, and evaporating dish. We will start with evaporating dish. This is called evaporating dish. Always make sure that the balance is 0. You should read 0, 0, so we're just gonna tear that. Make sure it is reading 0, 0. So this is the mass of evaporating dish in using the decigram balance. Record in your data sheet. We will record the same. We will record the mass of the same evaporating dish on centigram balance. That's the mass in centigram balance. Let's move on to milligram balance. Make sure always it is 0 to 0, 0, and we're good to go. Let's see. That is the mass of evaporating dish using the milligram balance. We are done with the fast apparatus. We will now do the same thing with evaporating. I mean the crucible with its cover. This is the cover, and this is the crucible itself. Crucible and its cover using the decigram balance. That is the mass of the crucible and its cover using the decigram balance. Using the centigram balance, please record on your data sheet. That is the mass of crucible and its cover using the decigram balance. Using the milligram balance, it is 0. Make sure it's 0 to 0, 0. Let's see the mass of the crucible and its cover in milligram balance. Please record on your data sheet. Last equipment is last class where you're going to take the mass is 125 LML flask. 125 in decigram balance. Let's see it. Make sure it is 00 before we weigh the plasma. And that is the mass of 125 LML flask using the decigram balance. In the milligram balance, it is 00, so I'm just gonna place there and see what the mass is. You need to record that in your data sheet. Mass of 125 LML flask using the centigram balance. And lastly, mass of 125 LML flask in milligram balance. That is the mass of 125 LML flask using the milligram balance. You may pause or you may stop the video and record the masses. In part C, you will record the mass of a known solid and determine its volume by calculation. Make sure that you record the unknown sample. This is unknown A, and this is the sample itself. This is the sample itself, which we are going to record its mass using the decigram balance. You need to record the mass of unknown. This is the decigram balance to one place of decimal. The same object in centigram balance. Please record the mass of the unknown solid A in your data sheet. This is the centigram balance. And lastly, the mass of the unknown solid in or using the milligram balance. Using the milligram balance, please record the mass in your data sheet. That take care of the mass in decigram, in centigram, and milligram balance. Place the unknown sample. Make sure you record the unknown sample in your data sheet. This is unknown sample A. You need to indicate the unknown sample number. This is unknown number, unknown sample A. That's the length. We will also do the thickness and see, the thickness or the length. Please record in your data sheet the thickness. I'll do the same thing for the width. I'll do the same thing for the width. It looks like it has the same dimension, so just record in your data sheet. You need to record in your data sheet the length, the width, and the thickness using metric ruler A. We'll also do the same thing for B. Next, we're gonna take the dimension or measure the length, the width of unknown sample A, and you can record on your data sheet the length of the unknown. You can record the length of the unknown on your data sheet. I'm gonna do the same thing for the thickness. I think it looks like it's a square. You can record the length or the thickness on your data sheet. I'm gonna do the same thing for the other side for the dimension, so that you can find the volume. I see that is the length, the width, and the thickness. Please, you may pause the video and record the dimension on your data sheet. In part D, this is the volume measurement. We will fill, or I'll fill the 100 ml. This is called 100 ml graduated cylinder. It's calibrated all the way. Make sure that the meniscus is at 100 ml mark. So what I'm gonna do is fill with just water. I'm just gonna fill all the way to 100 ml. So what I'm gonna do is adjust the meniscus. I'm gonna adjust the meniscus to 100 ml mark. All right, without overshooting, I got to place my pipette on the side. Make sure that the meniscus is at the right place. All right. Remember to record your volume with the correct number of significant figures as stated in the lab manual. Remember from part A, part B, part C, and now part D. You should always record your measurement with the correct number of significant figures and the units. Make sure that you can see the meniscus just right there. All right. Please now record the volume of water in 100 ml 100 ml graduated cylinder. Seems like it may be far off. Let's see if you can see. Maybe you cannot see from there, but I'm gonna adjust this and see. Sorry about that. I'm just gonna adjust my camera so that you can see the meniscus of the water reading in graduated cylinder. This is 100 ml graduated cylinder. All right, this is 100 ml graduated cylinder. Please record the volume. Make sure that you can see the volume. It is just right there at the mark. Okay. Make sure you record the volume of the water. What I'll do now is fill my 10. This is the 13 by 100 millimeter test tube. I'll just fill all the way to the top, and your job is to read the volume reading in the graduated cylinder. So what I'm gonna do now is fill all the way to the top, and your job is to read, and make sure you use the correct number of places of decimal or significant figures. All right, significant figures. So what this is you need to record the volume. I'm just gonna fill it all the way to the top. So now this is the volume. This is the volume of water in 100 ml. I mean 13 by 100 millimeter test tube. What I'm gonna put it on the side, and what we'll do is measure the volume of water in 100. You can see where it is. I don't know if you can see from there. Let me just put there. Maybe if I put a white background, you can read the volume. Let me just turn this on the side like this. Hope you can see the volume. You can read the volume of water in the graduated cylinder. Volume of water in graduated cylinder. These are right somewhere up there. Okay, so record the volume. Where is the meniscus? Somewhere around there. It's your job to record the meniscus. What I'll do is I'm just gonna fill it again, and the volume will drop. Okay, you're supposed to record that volume. That is volume 1. We will fill again. All right, I'm just gonna fill again the second test tube. I will fill the second test tube with water from the graduated cylinder, and your job is to record the volume. You will record the volume in graduated cylinder. All right, we'll see how this play around. Okay, I'm just gonna fill all the way up there, and you'll record the volume. You're gonna record the volume of yeah, that's good. So I have my second test tube, second test tube filled with water from the graduated cylinder. I'm just gonna place aside here and see if you can, if I can place properly the graduated cylinder or my camera so that you can see the volume. I want you to see where the volume is and record. Let me place the white background. Hopefully this will help. You see the volume of the graduated water in the graduated cylinder. Please record that in your data sheet. You got to record that in your data sheet. And that marks the end of volume reading. That is the end of the volume reading. Part D is temperature measurement. This is the last part in measurement lab, and what you can see right now is the laboratory room temperature in degrees Celsius. Please record that in your data sheet, and make sure you include the uncertainty as indicated in the direction. I know you can see right now it is 18. Make sure you have one place of decimal. What I want to show you is the water part. I mean the ice part. This is the setup, and what I have there is ice and water mixture, and I want you to record the record the temperature. Record the temperature. You may not see it clearly. Let me see if I can twist this to a place where you can read. That is the temperature. That is the temperature of water. That is the temperature of the water and ice. Please record that in your data sheet. Record that in your data sheet. It's now 1 minute and 30 seconds. Seems like the temperature is no longer rising up. That is what you need to record on your data sheet. The temperature of boiling water. Record the temperature of the boiling water in your data sheet. This is the end of our measurement lab. Next week or next lab, we will look at the concept of density.